Okay, and we're back. Uh, so I don't know if anybody had the chance to go through these exercises, or if there are any doubts on any of them. Might be worth trying to discuss them briefly. Uh, so the first one um, asked us to choose a commit message. So it gives 3 options. Uh, so it tells us something about the last commit that we did on Mars.txt. It's telling us, should we use changes? Should we use something like a added line? The mummy would appreciate the lack of humidity to Mars.txt. Or 3, discuss effects of Mars climate and the mummy. So I mentioned some guidelines on how to choose an appropriate commit message, and hopefully the solution is makes sense considering those guidelines. So the first answer is not descriptive enough. It just say changes, could be anything. Second one is redundant because the message, the changes that we did is included in the message, so just combine space. And the third one is probably more appropriate because it's short and descriptive. So hopefully that was not too difficult. Second exercise is about committing changes to Git, and it asked us about to choose the right commands, this right series of commands that will allow us to save changes to a file called myfile.txt to a local Git repository. So hopefully we're already more or less a bit more familiar with the Git commit workflow. So if you look at this, we'll probably have chosen the third one. That's the one I believe is the solution, but let's take a look. So yeah, so as we saw before, git commit will just add a file that is or had been added to the stage area. So you need an additional command previous to this one. Git init will initialize a repository. If a repository already exists, this has been initialized, you don't need to use git init again. Git add my file, that will put my file.txt on the staging area, and then we'll with git commit and the message will actually put those changes in the permanent region. And the last one, this one is similar to the first one, but it's not written well. It's actually willing to try to commit a file called my recent changes with the message my file.txt. So probably that doesn't make sense. Later, the following example exercise is telling us that the staging area can hold changes from any number of files that you want to commit as a single snapshot. And as asking us to do something. I don't know if you had a chance to do this, but basically it's telling us if you can add some text to mars.txt and then create a new file called news.txt, and then try to add those changes to the staging area and commit the changes. So it's very similar to what we have done before. So in here, you will probably need to use your text editor to open those files and do the modifications required. And then you will need to add those files, and you can use this command in here to add mars and venus.txt, and later on use this commit command to add any files that were added to the staging area. In this case, Mars and Venus, with a suitable message. So hopefully that's very similar to what we have done so far. And the final exercise was to create a new repository from scratch with some biographical data about you. So for that, you go up one level, or you go to a different directory that is outside of this repository that we're currently working on, and create a new repository and execute git init in that repository. Like here, you go up, create a new repo called bio, and enter that repository, execute git init, and then you need to create a text file with your biographical data. And then after you're happy with the file, you close your editor, add the text file, and then commit the changes. And you can review the change with the diff command. So basically, this is very similar to the workflow that you will be doing on real life in your local computer when you start working with on a new repo on a new project. So okay, hopefully there aren't many doubts, but do you have any, please put it in the chat. We will try to answer them. So moving on to the next lesson. So now that we know that Git keeps track of the changes on our files, and we have a way to explore those changes, let me just change back to my terminal. If I find the option, and yeah, bring it back. Right. So as we saw before, we can use this git log to show us the different commits that we have done in our repository, in our different files. We can refer back to this commits with identifiers. So those identifiers are these long numbers in here. The last commit has a special name that is called head. So this one will be the one that will be also labeled. Can be referred to as with this ID. Can be referred as head. You will see how that works in a moment. So let's try modifying again our Mars file. So here I will just add may consider change. And if I save this file, you can see it should look like this. And now you can, if I were to do this, git diff mars.txt, it will by default show me the last the change between my current modification, my current modified file, and the last commit. But I can also specify Git that I want to compare my file with a previous. I want to specify a previous version of my file to compare with. So for example, so by default, Git does this. You can see it's exactly the same output, only that I'm specifying which is the version I am comparing. So this is my current modified file, and this is the version that I am comparing with. So this is the last commit that I did. So this is the last version. So those two are identical. So, but I can tell Git I want to compare with an older version of my file. So I can still use this this label, this nickname for head, and just use this symbol. And what is the name? It's tilde, I think is the pronunciation. And if you do tilde plus a number, it will tell you, okay, head more or less like -1, like a previous to the last one, and should show you something like this. And you can refer back several commits. And obviously, if you go back too much, it will tell you that there is no older versions. That's how you can. That's one way to compare with older versions of your files. Another thing you can do is to so this diff option shows you how your current file is different from the version that you specified in here. So my initial commit that only had one line, the difference is these two new lines, including the last that we just add to our file. So that's how git diff works. But you could, for example, using instead of git diff, you can use show, and that will show you. If I do this thing, yeah, in here, this will show you the commit that you had, the first commit that you did. So in this case, this was our original message, and the original file that was committed. So that's how it differs. And you saw that the head in the previous command, I used show diff head type hyphen tilde 4 to show the difference between the first version of the file, and with show I use the tilde 3 to show the corresponding commit. And you can see here that it's telling me that this is the first one, because it's no first one, but don't want to confuse you with that. So this is how you can explore two things. One is the difference between a previous version, what was modified between the previous version of a file and your current version, that is with git diff, and the version of the file you want, and what was the commit message that you received on that previous version, that you can access that with git show. So that's useful to get more information about what was happening. You can also use, as I mentioned before, you can use the you can use the unique IDs of every commit. So, for example, I could do this, git div, and if I, for example, use this one, that is the first one, I do Mars, hopefully that will work. And I'm asking now Git to compare, give me the difference between my first commit and my current file. So tell me that the difference is, well, yeah, I have these two new lines. That's good. But maybe that, it's really too long to type all this long message, even if I copy it. For that, what I can do instead, as I showed before, is use the git log -- one line, and it was showing us before the shorter ID. But if you see, just the first characters matches the long ID. But you can use these numbers instead. If I copy those, you can do div, and it will show me exactly the same output. So those are different ways to get the same result. So I don't know if everybody's with me at this point. If so, let me just see what I was. Is there any way to look up date from that number? Yes, you can typically git log will print this, right? Typically, this list will be longer. So one way to look for a date could be you can parse this output with another command line tool, for example, grep, that is this. So if I were git log, and I can try parsing this grep, and then we're looking for, I don't know. The thing is all of them are have the same date. Say, so I can match a file. I can match a line with that specified string, and I can add some options to grep, and it will give me so basically I'm asking grep to search for this string in this output, and to give me a context, so that 3 lines after and 3 lines before that match. So this is a different tool that is independent of Git. That is one way to do it. Another way to do it is that once the output of git log is long enough, it will show in a different screen, and within that screen you can type a /, and that will let you, after you press / and you type any string, it will let you search for that string within that buffer, within that display. That's another way to do it. I think during the course we won't reach a point where git log, the output of git log, is long enough. But I think the instructions are in the training material. But that's another way to do it. And also, I believe if you look at Git manual, I think there are specific options where you can print commits within a specified range of time, which I don't remember from the top of my head. But yes, there are different ways to accomplish that. To accomplish that. So now moving on. So let's say but it was. So yes, I was telling you that you can access the same same behavior with a shorter ID. You don't need to specify the long ID. Now, say that you want to say that you want not just know how it changed, you also want to actually see the file. Like, can you actually see how that file looked at that point? It is possible. So you can use git checkout and provide the ID for the commit that you want to check out. So in this case, we will use the ID for the first commit. And I give the file that I want to check out. And now it seems like nothing happened, but if you check the content, mars.txt, you see now that my file changed actually, and it has only the content from the first commit. And if I do git status, it's modified my file. So in this state, I could explore how my file, in the state of my file, in case typically you will do this with a longer file in a completely different version, and you want to check how was written or what options were set in that file, etc. Say that you finish out the file, you want to go back to the current version. So for that, you need to git check out and now provide the nickname. You could do the latest commit, or you can use just the alias for that ID that is get. And you go back and if you add parts, and now you realize that I also lost, or I'm not seeing this the latest addition that I did to my file. But that's a good way, for example, to get rid of any additions of any mistakes they have done. Yes, exactly. It's not permanent. Just to review a previous version. Yes, and you can revert back to the current one with a checkout head. However, there is a warning here. I should take into consideration. It is. Let me just clear the screen so that it's clear. So, and if I do git checkout, oh, not that one. Git log, one line, and I do git checkout, and I go back to my first commit. And typically, what I showed before was that I should provide the name of the file I want to check out. If I don't provide a name, if I just do this, what will happen is that I receive a warning from Git, and it's telling me that you're in the detached head state. So what happens is that Git is sort of it's not understanding, or maybe it's understanding something different. So what he's doing, if you pay attention here, is that he's reverting everything back to how it was originally. all the files. So my directory spaceships is gone with all the files that were inside. Well, it's not really gone. It's just Git just is taking me back to the previous version, and it's warning me that I shouldn't make any changes in here. But if I do, if I want to keep those changes, it's suggesting me how to do it. It's about checking out a new branch. Branches is not something that we'll cover on this course, but probably you should be aware that how it works with Git is that you have a main, master, branch, and that's typically where you work. But branches are useful when you want to do experimental changes that you're not sure you want to keep, or maybe side projects related, but maybe not in part of the main project. So branches are useful for that kind of situations. However, as I mentioned before, we won't be seeing those on this course. There's another course, an advanced course that that covers in part, and that's where as Tom mentioned, that's where confusion with Git starts. So, but just it was worth using this option in here because that's a typical gotcha, and sometimes you type it by mistake and you don't know what to do. Like, okay, how do I go back? Everything disappeared. So in this case, you can just go back to your current state, and you can just if you do, you can just go back to Git checkout, and as I mentioned before, your main project, your main your current situation can be referred also as master. And then if you type ls again, you see that you are back home and everything is where it's supposed to be. So I relate to this because the first time I hit this problem when I was starting to use Git, it scared me a lot, and I thought I suddenly lost everything that I have done. So I spent several hours looking for answers on Google because I wasn't sure what happened. So hopefully will save you some time, some panic moments. That's possible, I think. The way to do it, maybe Juan and Tom can also suggest something, but I believe the way to do it would be to revert back. Okay, if I were to do git log -- one line, you will be using the ID for that commit, then probably is the second one, because we only been adding one line per commit. And once in that state, once all the files have been reverted back, you can create a new branch with this command in here, and then use that branch and merge it to your main master branch. In that case, that you could bring the changes forward or revert back to that situation. That's one way to do it. Probably there are others. But that's the one I'm familiar with. So now, just clear my screen now. Let me check the status of my. Yeah, that's another way to do it. So in Git, there is here an option. There is an exercise about how to recover older version of a file. So maybe there's something like could be useful for what Peter asked before. So in this hypothetical situation, we have a user, Jennifer, who has made changes to some Python scripts, and she has been working on for weeks, and those modifications broke something on the script, and she has spending some time and hasn't been able to fix it, and wants to revert back to the old version. So that's very typical. So as before, if I were to open my file Mars, and I again type the ilg change, and I save this. So say that that's the changes that we have made for an hour, and we're not sure how to revert back because trying to erase what we just wrote will take a lot of time, and we're not sure we will actually be erasing only what we just added. How do we use Git to go back to the latest version, the latest working version? So the material has an example how to do this, and it's asking you, how would you do it? Well, there are a couple of ways to do it. So first one is, the first one that could be using is git checkout head. But in the material, that's a dangerous one because this will revert back everything on our current repository. So we're asking Git to revert back or check out the latest working version. So if we're only working with one script, that's okay. But say that we have a few scripts and that a few modified scripts and some libraries and some data files, and a lot of them have modifications. If we use this command, we're asking bring everything back to the latest working version, everything. So that's not recommended. So the recommended way to do it will be to use only the name of the file that you want to revert back to the latest working version. So this is how you typically would do it. And then if you cat this file, you will see that now the modification I did, the extra line is gone. So for this situation, now Jennifer is back to how the script was before she started modifying. So that's something useful in a real world scenario. So there are a few examples in here. If I change my screen here, if I just few exercises. Recovering older versions of files, the one that I just explained. But if you want to take 5 minutes to go through these other exercises and try to understand what they're referring to see if you can come up with a solution, that would be useful. So that if you have any doubts, you can ask those doubts now and try to see that if everything is landing correctly. So if we could just spend 5 minutes going through these exercises, we'll be here, and please ask any questions on the chat as you go through them. We will be paying attention to the chat. Well, I'm trying to use the poll to get some answers for the first exercise, understanding workflow history. So not sure if it will work. Let's give it a go. If you can, there are four options, and so the exercise is asking you to consider the series of commands in that exercise and try to guess which would be the right output. So if you have look at those commands and look, thank you. Right, thank you. What about now? Is it better? Right. I was changing to some headphones to try to listen better, but doesn't work. Right. So let us try to use this poll feature on the platform and see if that works. So this exercise is asking us to consider series of commands to see what will be the output. So it's asking us to go to the planets directory and echo some text to venus.txt file, and then to add that file to the staging area, and then to echo a new message, a new line into this file, and then commit the file, and then to check out head venus.txt, and then try to print the content. So what would be the content printed? And there are several options. Would be only this last line, only the first one, both lines, or maybe we will get an error. And you don't need to do this necessarily, but it helps if you do it. But if you go through it, you probably see. Let me just change back to my, if I can, there. Share my screen again. Blank. And I'm back to, yes, that's good. So let's try this. So I'm currently on my planets directory. So if I do echo Venus is beautiful and full of love, and I send that to venus.txt, which currently I don't have any. And I get that at this moment I have one line, and I do git add my Venus file, and I do another line, and I send it to, again, venus.txt. And now it's asking me to commit my file comment and I do this, I commit my file, and then it's asking me check out head. So revert back to my previous commit. And I cat benus.txt. What happened? Ah, I only have one line. So I lost my last line. And the answer would be 2. Yes, cool. And so let us stop this. And so what just happened? Why did I lose my last line that was Venus is too hot to be unsuitable as a base? So in here you can see a solution, and hopefully will explain you what just happened. But basically, what we did was we created a file and we added a line on the file in here and added that file to the stage area. So, but after we added the file to the stage area, we added another line, but we didn't add those changes. We commit the file, but the only changes that we actually added were right here, right after we added the line. So after we committed the file, this will be the last commit. We ask Git to take us back to the last commit, revert back our venus.txt to the last commit, and that commit only had the changes corresponding to the only one line, and that's the reason why we lost the second one. So hopefully that makes sense. And there are a few other sections here, and I don't know if anybody had any time to go through them, or there are any doubts, or you want more time to go through them, perhaps. Also valid. If not, we can try to discuss them briefly. And the next exercise asking us to check on our understanding of the give diff command. So we have this diff head 9 marks.txt, and that probably will give us an error because we didn't have as many commits. So let us use less, let's say that one. And so that original file to throw an error because Git didn't go as back as we requested. There was 9 commits, so it shows an error. Now, next exercise is getting rid of stage changes. So it's just asking us to do some changes to add some changes to our mars.file and get rid of them. So, right, more will consider changes. And this is how it looks. But this time it's asking us to actually add the file to the stereo. So let us try doing that. Git add Mars, and you can see git status. Now this my file is now ready to be committed, but we won't commit it yet. At this point, we decide that we won't want that change. Let us see if we can revert back. Hopefully, check out Mars.txt, and let's see if that happens. And that happens. That's another way. So you can revert back changes even if you just added them. It's different if you just committed the changes. There is a way to do it, but that will be covered in another section. For now, let us go to the last exercise. That is exploring and summarizing histories. So let me just split my screen. So before I show you that you can use git log and different ways to modify the output, but if you have different files, and many of those files have been modified, although those changes will probably be added to the history or different commits. But say that you only want you want to filter the history through the changes that that pertain to a particular file. You know, in one commit, Mars wasn't changed. You don't want to see that in the history. You only want to see commits that included Mars.txt. So you could do this, but let's say here this is not doesn't look really useful. But actually, you can see that you have less commits in here, since at least one is only pertaining to venues in my previous output. But in here, I just requested those that were related with Mars. So it's just showing me those where Mars changed in some way. So that's one way to do it. You could, for example, do something, add another flag, and let me just repeat that, but with my display, with my screen clean. So I put my screen and I repeat the command git log -- patch mars.txt to see what happens. So this is the output, and here it's actually telling me what happened on those commits. So it's actually telling me that in which way Mars changed specifically, rather than before that was only showing me the commit message. So that's one way to filter out changes to specific files. So okay, that's so useful in many situations. Let's move on. So now Peter is asking, if you made a mistake when you do a commit and you left the file untracked and you edit the commit, or is it better to go back and redo it, adding the file and then doing the commit? What I would do is, after you did that commit with the missing file, I would probably, after that commit, I will add the file and do a new commit, specifying that this is part of the last commit, something meaningful in that message. Probably that would be the easiest way. But I don't know if Juan or Tom had other suggestions. So okay, so far we have been trying to familiarize with what is the typical workflow in Git. That is, initialize your repository with Git init. You create some files, and then you add them for Git to keep track of them, and then you commit the changes when you're happy with those changes, and then you modify again those files, add them again, and commit. And that's typically the normal workflow. There are many other things you can do with Git that we'll be seeing in a moment. But let's say that you want to ignore things this time. Say that your scripts are producing some output files, and you don't want to keep track of those, since every time that you hit git status, it will crop up and it will clutter that output. So let us test this. So I am in my planets directory. So if I do a new make there, results, and I create a few dummy files, results out, results out. So I'm just creating empty files, and the only reason for this is so that you can show you how it would look if I do git status. So these files might be the output of my scripts, but they suddenly appear, and now if I do git status, Git is showing me you have a few files that are being untracked. But if my script were to create hundreds of those, you will see a very, very long list full in red. So, but maybe you don't want to, those are temporary files. You don't want to keep track of those, and you don't want to see them every time you do git status. How do you avoid that? So Git has a way to do it, and the way to do it is through configuration file that is called Git Ignore. So the only thing that you need to do is to create a new file in the directory in your repository that is called, well, it starts with a dot, and then it's Git Ignore, like that. So you open this file and modify it. In this file, you can add all the different files that you want Git to ignore. So in here, for example, if I want Git to ignore any files that finish that end in .dat, you can do this with some special symbols, wildcards, .dat, and this will tell Git to ignore any file that is the symbol in here, the star symbol, and then that finishes on .dat. So now if I do git status, telling me that there is this new file, but it's still showing me results. So basically, because it's a directory that is not empty, right? If I don't want to see results in that output, I can go back to my text file, to my git ignore file, open it again, and do results. And anything that starts with results will be ignored as well. If I do git status once more, you will see that now I only see Git is only saying one new file, that's git ignore, and well, Git ignore could ignore itself, so that we don't need to keep track of it. But sometimes, I mean, the recommended approach is to also keep track of this file, since if we were to share our repository with somebody else, and the odds are that they will also want to ignore the same things. So if we already have a file that is tailored for a current repository to ignore the things that appear on it, we probably want to share it as well. So we probably want to add git ignore, and then the same workflow that we have been doing. We add the file to the stage area, and then we commit the file with some meaningful message. So, and that's it. And then we do git status. Everything's clean. Now I'm tracking my git ignore file. And as a bonus, this git ignore file also allow us to by adding by mistake some output files. For example, if I were to add or try to add .dat, this file that is currently in my directory, Git will throw us an error message saying that this kind of files, those ending in .dat, are currently being ignored by my git ignore settings. But it's also letting me know that if I really want to track it, I could do it by adding the -f flag. So if it wasn't a mistake, I could go back and say, yes, I want to do it, and then add the -f, and force it to add this file. But this case was a mistake, so I don't want to add it. So okay, what if I want to see which files are being ignored? So let me clean my screen, because once added to the git ignore list, I won't be able to see them. So, but by default, I mean, you can ask Git to show you just those files that are being ignored, like this, and you will see in this case that these are the files that are being ignored. In case you want to review them. Here there are some exercises about how to ignore some other files, depending on if they are on nested in some depending on your directory structure. It might be the case you want to ignore some files and not others, and so on. But I will let you probably do these exercises by yourself, and probably show you something else that will be useful, because at this point we only been working on a local repository. But what if you want to actually collaborate with other people, or maybe you want to have a backup, an online backup, because you have different, you're working on different computers. You have one in your lab, in your laboratory, you have another in your office, and you also have your laptop at home. What if you want to have all your files in sync? Well, the easiest way to do this is through creating a repository, an online repository in GitHub. It has several advantages. It has a nice interface, very useful. It is free. It's public in case you want to, point your colleagues to that repository to, for them to see what your latest scripts or data are. You can let them know with just with providing them a link, and they can download the latest version of everything you have. So I would like to know if any of you have any GitHub repository at this point. And if not, maybe worth going together. Pablo has one. That's good. I don't know if anybody else. Sarah as well. That's good. All right. Yes. Because the next lesson is about trying to go through the process of actually opening one. So it's worth saying if you have one or not. A few people who have one, that is good. So if you have one repository, then that simplifies things, and we can then just show you how to create a repository for your current directory that you have in your local laptop. So let me try to do that. And bear a second with me. Application screen. I will try to show you my browser. Yeah. So here in the training material, you see that you have a few instructions on how to set up a remote. So you can read through this, but in essence, what you want to do is to go to GitHub, your GitHub account, and here the display will probably be different. At the moment, I have mine in a weird setup. Like, let me just resize this, and that looks more like it. Yes. So in here, what the instructions are telling you to do is to go to this section and create a new repository in here. So hopefully we are on the same page in here. If not, please let me know. Maybe I might be going too fast. And the instructions are telling you to, how to fill this this form basically. So it's telling me what is the name of the repository I want. So for this exercise, I created one, but I did this before, so I already have one that's called Planets. So we're going to Planets 2, just for the sake of this exercise. And it will let it as public. And it gives me some options about adding a README file, adding a Git Ignore, and choosing a license. At this point, all of these options should be unmarked. You shouldn't select them, because if you do, they will create a file, but in your new repository. And when you try to link your local repository to this remote one, Git will complain, because it will notice that there is a file in the remote repository that is not in your local repository, and will tell you this is not the same thing. It will throw an error. So it should be empty. So don't select any of these. So then just create a repository, and that's it. And now GitHub is telling you some options in here that you can create a new repository on the command line. by using git init, as we did at the beginning of the lessons. Or maybe you can use one that you already have and link it to this remote one, and it's telling you how to do it. So if we go back to the instructions in our training material, and I scroll a bit, you will see here that we're seeing exactly the same. That's good. And also telling you that once you link your local repository to the remote repository on GitHub, what effectively is happening on the remote server is a series of commands. They are creating a new directory. They are changing to a directory and running Git init. So similar instructions by default are being executed on the remote server. That's what is more or less what is happening. So at this point, you will have something like this. You have your repository, your local repository on your computer that looks like this. Then we've been working with this up to now. And on the remote side, you will have something empty like this, nothing in there. But now, if you want to transfer your local files to the remote server, so they are available and backed up, and you can do that following instructions on GitHub. But just a quick mention of you will see these options, HTTPS versus SSH. And the instructions that we will be using, they can be followed with both ways to connect. There are just two ways to connect to GitHub. Those familiar with Mac and Linux will probably understand what SSH is. But the recommended version is HTTPS, just because it's everybody that either in every platform can use it more easily. But if you already have some SSH setup configuration in your local computer, you can go ahead and use that one. But we will be using HTTPS. So what the instructions told us to do was to run this command using your own username, of course. So in my case, let me just go back to the other tab. This is the same command, just that in here I have my own username, and that's what you need to use. You will be using your own username. So if I copy this command in here, and let me just go back again to the instructions, and I will now sharing again my bash terminal. I think so. Hopefully you can see it. Right. I got nervous for a moment. And so, okay, going back. I copy command from GitHub, and I will just paste it in my current planets directory, my local repository. And what that command was this. And if I go back here, is git remote add origin, and this basically is origin can be other word, but we won't discuss that. But basically, what this command will do is to link my local repository with my remote one that I just created on GitHub. But of course, I need to use my own username. So, and that's it. It should be linked, hopefully. And now I can double check if we actually added the right one. And it's telling me yes, the origin now is set on this remote repository for fetching changes and for pushing changes. So now, how is this useful? So what will happen is, well, yes, you're right. Of course. Thank you, Sachin. It's actually I did planets too. Yes. So let me change that. And actually now I got into trouble. Let me see. How do how can I reset my remote? No, it's not there. If yeah. Let me try removing my remove. I just made a mistake in here. Origin, and I try to add it again, and if I list it again, yeah, that's okay. So thank you, Sachin. I forgot that because I did already this on my some other time. I already used planets and I forgot to delete it, so I'm using planets too. But you should be okay using planets. So now, what is this? Why is this useful? So now, what you can do is to do Git Pull, and now do. So basically, you want where do you want to push your local files, and what version of them? So because we only have one local version, that is the master one, and that's the one we were using. And if you do that, it will probably prompt you for your username in case it's not well configured. So mine is this, and my password, and it will upload everything. So now, if you were to go back to your repository on GitHub, and if I change back screen to and I'm back on GitHub on my repository planets2. If I hit on code, you will see now that it was previously empty, but now I have all of these files have been created, and now they're available for other people to see and to work with if they want. The way that this will work is that if anybody wanted to, collaborate with me, they could just get this this link in here in code, and let me just so I just copy this linking that is in here. Let me go back to my terminal, and we will pretend for a moment that I'm a different person, that I want to collaborate with my other self, and And again, for some reason, I cannot see my terminal when I try to go back. Right. There you go. So let me just go to my home directory, and I just create a new let me clear the. Let me just jump to desktop, and I create a user 2. And I jump there, and I say that I am a different person in a different computer, some other place in some other part of the world, and I want to collaborate with a person who owns planets too. Okay, in that situation, what I can do is to use this git clone command and give the link that I copied from GitHub. That's a link to my repository. So, and it will clone everything, and you will see that I have it's doing here. I jump here. I have exactly the same files in the last condition, the last commit that I did. All of them are in here, and so this version has a copy of how everything is the current state of my files at the time they were cloned. So up to this point, that's how you initialize the collaboration. That's how you create your own remote repository, how to link to your one, so that you can personally have a copy. You can point to other people, and you can clone that copy onto a different you have access to. And how this will typically work is that if you do, say that this other person do additional change. Let me just do. So this change. So the typical workflow will be you modify a file, add that file, and then commit. Thank you, Peter. Git commit and do some more thoughts on Mars, and you do the -m, of course, and then up to this point the commit is only on the local version, but you want to make it available on the remote server for your collaborators or the owner to be able to see them. What you need to do is to do, or yourself maybe, that you're working on your laboratory or on your personal computer, and you want to have access to that change later on when you go back home or somewhere else. What you need to do is to push that that change to your remote repository. And it will probably ask you if you have access, if you're allowed to push to that repository. And now it went up, and it was the copy to the remote repository. So if I go back now, say that in my I am the owner, or I go back to another computer where I want to have a copy. So this was the previous, the original version of Mars, and I want to, and I want to know if there were any changes on on push to the remote, and I want to synchronize my local version now with what was added to the remote version. The flow is I go git fetch and do it will tell me that there were some changes, and do now git pull and mode origin master. Yeah, so forgot to add that. And now if I show the content out of my local Mars file, I can see that now I added that change. So that is a typical workflow when collaborating, with somebody else, or maybe yourself in different computers. Just making changes in one system, pushing them to your remote server, and then fetching them on a different computer or by a different user or collaborator, and so that all the copies are in sync. So probably covers the main features of Git at this moment. Git has lots of other nice features that are useful. That probably didn't have time to cover on this lesson, on this course, but are available on the material if you want to take a look. But don't know if I have any questions at this point. Probably a few, but I can probably stay around for a few more minutes if there are any pressing questions or pressing doubts about this the workflow that I just try to demo. If not, well, thank you very much for joining this session, and hopefully it was useful, and you learn the basics of how to work with Git, and probably will let you start and find out more about how to collaborate with Git.